I've loaded my climate change project. This project was designed to be interacted with in the Camtasia editor, but it was designed never to be produced. And that's because the project itself runs for almost 16 hours. The project is laid out in 5 panels. Each panel represents a different time history in Earth's past. We're currently looking at the first panel. The first panel covers the time span from the present, which is located here on the left edge, to 20,000 years ago on the right. This panel has 3 primary graph lines. One is this blue line here that covers the Earth's temperature history over this 20,000 year period. This line here is sea level covering the same period. And this line here covers the value of CO2 in the atmosphere. Each one of those lines has their own scale. The temperature scale is located here. That's these values going from plus 25 degrees Fahrenheit to minus 10. The sea level scale is over here. It goes from 0 down to minus 140 meters. The CO2 scale is here. It goes from 180 parts per million to 300 parts per million. There's a point on the CO2 graph that's up here. This value up here is about 410 parts per million. There's a blue call out here that indicates the period in time that the panel is currently displaying. Notice that there's a red X over here currently at the left edge of the chart. We can move the X by playing the timeline. We'll play by using these little controls here to index one step at a time. You can see that the call-out values have changed to indicate the current location of the X along the temperature line. Note this thin black line here. This thin black line is over top this X and it travels with it. And you can use this thin black line to look up to the sea level curve or the CO2 curve and see where those values were at the corresponding time period indicated by the call-out. The Camtasia editor has some grid lines you can use to find things in an X or Y basis. I'm going to expose that using Ctrl-Alt-R. You can see those grid lines here. There's a horizontal grid line here that you can move. And I'm going to move it so that, in this example, I'm going to superimpose it at the intersection of the vertical line with the sea level curve. And by following the line over the horizontal line, I can see that that corresponds to a sea level value of approximately minus 24 meters. So at this point in time, sea level was about 24 meters lower than it is today. Today being 0 value here. And I can hide the extra horizontal line again by using Ctrl-Alt-R a second time. There's also a blue call-out that provides information on significant geological events as they happen through time. This will change as the X moves along the project. Additionally, there's a little PIPMP4 that plays, and it will display the changes in the location of the continents around the Earth due to plate tectonics going back in time. Each panel in this project, and there are 5 panels, will be described textually in the lower left corner. And the geologic epoch that's currently in view is described in the lower right corner. Now, the project has 5 panels covering 5 different time frames. Again, we're currently looking at the first panel covering the present on the left to 20,000 years ago on the far right. I'm going to navigate to the next panel. Here we are at the second panel. This panel covers a period of time on the left at 20,000 years ago to 1 million years ago on the far right. We navigate to the next panel. This panel covers a period of time from 1 million years ago on the far left to 5.5 million years ago on the far right. We'll navigate to the next panel. This panel covers a period of time from 5.5 million years ago on the left to 66 million years ago on the far right. Now navigate to the last panel. This panel covers a period of time from 66 million years ago on the far left to 550 million years ago on the far right. We'll navigate to the beginning of the project. I previously mentioned that I can use these controls to cause the time indicator or the little X to move across the project. This rate of change will vary depending upon which panel you're looking at. Here we've gone to the next panel. You can see that the little clicks that I'm making don't move the X very much. In those cases, I can cause the X to move by using the L function on the keyboard. And I've hit it a couple times, and so the X basically tracks along the temperature curve. And again, we could follow where it is on the sea level and carbon dioxide curve by looking up this vertical line. The rate of change you see here, and I'll speed it up as fast as possible, this is going to change when we get to the next panel. Each panel will cause the X to move at a slower speed. We're currently running as fast as we can, but the X is not translating as fast as it was. Notice the time period is really clicking off. Here we're coming up on almost 2.5 million years ago in the past. Again, I've got the X going as fast as it can go. I can't play the timeline any faster than I'm currently doing this. We're now at the third panel. We're soon going to go into the fourth panel. Here we are. Notice that the rate of movement is very slow, even though I'm translating the timeline as fast as possible. And you'll notice that the time frame here is indexing a lot slower because this particular chart goes from 5.5 million on the left to 66 million on the right. We're not going to let this play all the way through. What I'm going to do is stop play automatically, and then I'm going to scrub using this, and that'll move the X. Not as smooth, but it gets us there, and we'll pretty shortly be in the next panel. The problem is the same here. Time is so long here, going from 66 million on the left to 550 million on the right, and the X would move extremely slow. So once again, I can move it by translating it manually by just scrubbing the timeline. And usually this is the best way to navigate around the third, fourth, and the fifth panels. Now I'm going to walk this back, and I want you to pay attention to the display up here, which is the plate tectonics changing the look of the Earth. And I'm just scrubbing now, and you'll notice how as time changes, the look of the Earth's continents changes dramatically. Various supercontinents show up. And at this point in time, we've changed the style of the PIP graphic. And that's how that works. And I'm going to navigate back to the beginning of the first panel. One generally consistent item among the 5 panels in this project is the temperature line and the temperature scale. Specifically, the current Earth temperature line, which is represented by a horizontal black line, and that line runs basically right along here, as well as its temperature scale, which is the scale here going from plus 25 degrees Fahrenheit to minus 10. Now, we're currently looking at the first panel. We navigate to the second panel. We'll see that the current Earth temperature represented by 0 is here as it was in the previous panel, as is its scale. We'll go to the next panel. The same 0 temperature line here and the same scale. Go to the next panel. The 0 temperature line here and the scale is here. Now we'll go to the last panel. 0 temperature line here and the temperature scale is here. We will examine each panel in the project, so pay attention to how the temperature, carbon dioxide, and sea level changes as a function of time. This particular panel covers the period of time from 550 million years ago on the far right to 66 million years ago on the far left. Note the wide extrusions in both temperature and sea level. Carbon dioxide starts off at a very high level of about 7,000 parts per million and gradually descends to about 1,000 parts per million at 66 million years ago. These carbon dioxide values are significant considering that current carbon dioxide in the atmosphere is only 410 ppm. Furthermore, I'll point out that temperature about 550 million years ago was running almost 25 degrees Fahrenheit warmer than today. We'll navigate to the previous panel. This panel covers a period of time from 66 million years ago on the far right to 5.5 million years ago on the far left. Note that Earth's temperature started out at about 18 degrees above present value, then encounters a relatively steep increase back up to close to 25, but then gradually cools off and ends up at 5.5 million years ago at around 5 degrees above present value. Carbon dioxide starts off at about 1,000 parts per million, experiences that same interim climb, and then ends up gradually decreasing to about 450 parts per million at the 5.5 million years ago point. We'll go to the previous panel. This panel covers a period of time from 5.5 million years ago on the far right to 1 million years ago on the far left. Note that the average temperature starts off at about 5 degrees above current value, but very gradually descends to fall below the present value and ends up at 1 million years ago at about 3 degrees below present value. I'll point out that carbon dioxide starts off at about 450 parts per million, but then basically remains almost flat, maybe ending up at 380 or so during this period of time. The period of time is indicated by this red bar you see here. This is the part of this curve that this time frame covers. So what we have in this panel is a period of time where Earth's temperature gradually cooled off and carbon dioxide did not change very much. I'll also point out that all these little excursions you see in the temperature chart here have to do with periods of glaciation, because there's ice sheets on both Antarctica and Greenland, and glaciers were advancing and receding. Earth was getting colder and warmer, but on the whole, Earth's temperature was cooling off. And that corresponds with what you see here in a gradual reduction in carbon dioxide. We'll go to the next panel. This panel covers a period of time of 1 million years ago on the far right down to 20,000 years ago on the far left. Note that the average of the temperature curve here remains fairly flat, but generally indicating the temperatures average about 5 degrees colder than today. And also note that the excursions have spread out quite a bit from the previous panel we were looking at, and that's because the deviations here are based upon a 100,000-year cycle, where in the previous panel, they were running at about a 41,000-year cycle. You'll also see that carbon dioxide during this period of time varied between a low of 180 parts per million to a peak of about 280 parts per million. Again, staying relatively flat within this span. I'll also point out that these deviations you see in the temperature graph here are due to Milankovitch cycles, which are 100,000-year cycles that are being driven by the Earth's orbit around the Sun. And these peaks you see here are called interglacial periods. We are currently in an interglacial period, and the one here is the previous interglacial period. And the downslopes you see here are called glaciations, where the Earth gets really, really cold. The time span variations between interglacials and the glacials runs about 20,000 years for an interglacial versus 80,000 years for the glaciation period. I'll also point out that on the sea level chart here, sea level mirrors the general same cycles as both temperature and carbon dioxide, and that's because sea level is a function of ice being trapped in glaciers, and sea level goes up when glaciers melt, or we're in an interglacial. And sea level goes down when glaciers form and lots of water in the ocean gets frozen up in the form of ice. We'll go to the first panel. This panel covers a period of time of 20,000 years ago on the far right to the present time on the far left. Note that 20,000 years ago, temperature started out at about 8 degrees colder than present, gradually rose for a period of 8,000 years to the present value, which is where you see this black line here. And about 12,000 years ago, it reached this level and stayed relatively constant for that 12,000-year period all the way up to the present. Carbon dioxide, likewise, started out 180 parts per million, gradually climbed up throughout this entire period to about 280 parts per million until about 200 years ago, where it climbed steadily to the present value of about 410 parts per million. I'll point out that although there is this apparent spike in carbon dioxide, there's no corresponding spike in sea level or in temperature. Earth's temperature here, under this carbon dioxide, spike is only about 1 degree higher than it was from the average of 1960 to 1990. Sea level here is only up 8 inches since 1990. Again, I'm going to point out that we are currently living in what's called an interglacial. So Earth's current temperature, which is about 57 degrees Fahrenheit, is considered warm compared to what it used to be back in the days when glaciers were everywhere.